Every single time I ask an AI a really complex question, or even just marvel at a beautifully rendered frame in a video game, I kind of forget that I'm forcing a computer to do this colossal, mind-numbing math chore.
Oh yeah, the matrix multiplication. It's happening behind the scenes constantly.
Constantly. And today we're doing a deep dive into a brand new paper from researchers at Google DeepMind, MIT, Columbia, and CMU. And our mission is basically to uncover how machine learning literally just broke a major mathematical speed limit for doing this exact math.
Which is just fascinating because, when you're dealing with billions of data points, even a microscopic shortcut saves immense amounts of computing power and energy.
Right. It's like manually matching billions of spreadsheet rows and columns. You want any shortcut you can get. And actually, speaking of deploying AI efficiently, if you need help with AI training, automation, integration, or even software development, this deep dive is sponsored by Embersilk. Yeah, if you're trying to uncover where intelligent agents could make the most impact for your business, you should really check out embersilk.com, because finding those elegant efficiencies is the whole point of today's story.
It really is. And mathematicians measure this efficiency using what's called the matrix multiplication exponent, or omega.
Okay, omega.
Yeah. And in 1969, a mathematician named Strassen proved that it takes less than, O of n to the 2.81 operations.
Right.
And recently, mathematicians used a highly complex technique called the laser method to lower that bound to about 2.371.
Right, so they're trying to push this boundary further, going from what they call recursion level 3 to level 4. But to do that, the optimization parameters just exploded, right? Like from 25,000 to nearly 7 million.
Exactly. 7 million parameters.
Oh, wait, I have to challenge this for a second. Why couldn't researchers just brute force this? I mean, we have supercomputers simulating entire galaxies. Why is 7 million parameters suddenly a roadblock for our hardware?
Well, it's because of the sheer non-convex complexity.
What does that mean exactly, non-convex?
So imagine you're trying to find the absolute lowest point in a massive, dark valley.
Okay.
If the valley is a smooth bowl, you literally just walk straight downhill until you hit the bottom.
Right, that's easy enough for a computer to trace.
Exactly. But this problem is non-convex. The valley floor is covered in millions of jagged craters, hills, and random traps. So if you just step downhill, you might get stuck in a shallow crater instead of finding the true bottom.
Oh, I see. So a supercomputer trying to brute force every possible path would take lifetimes.
Lifetimes. You can't just throw raw power at it. So the team didn't use brute force. They translated the problem into parallel hardware using JAX.
Okay.
And then they deployed AlphaEvolve, which is an AI coding agent.
Wait, an AI writing code to solve the math?
Yes, to literally mutate, evolve, and improve the optimization algorithm itself over generations.
That is wild. So the AI is mutating its own logic to find a shortcut human mathematicians couldn't see.
And it worked. It resulted in a brand new world record bound of omega being less than 2.371177.
Okay, but here's where my skeptic alarm goes off just a bit. AI calculations use floating point numbers, right? Like decimals.
Right, they do.
So how do we know the AI didn't just stumble onto some tiny rounding error and we're just accepting a hallucination as a mathematical breakthrough?
That is a great point. And the researchers anticipated exactly that, because a tiny rounding error is totally unacceptable in theoretical math. So once the AI found a solution using decimals, they translated the entire thing into exact rational arithmetic.
Right, pure fractions.
Pure fractions. So instead of a decimal rounding off, they mathematically guarantee that the proof is absolutely flawless.
Oh, wow. That is brilliant. Taking an intuition from an AI and locking it into perfect mathematical certainty.
It's incredibly inspiring. We are successfully using modern machine learning to conquer 40-year-old open problems in theoretical computer science.
It's the ultimate positive feedback loop. Matrix multiplication is the core math that runs AI in the first place.
It's the literal engine of machine learning.
And now AI is optimizing its own underlying math. It leaves you with this thrilling idea. Are we entering a beautiful era of self-accelerating human discovery?
I really think we are. The future looks incredibly bright when we have tools like this.
It's such a hopeful thought, a mind-numbing math chore turning into a key for unlocking a brighter future. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.